Hi everyone, here's a solution to the coding challenge, probability of greater. In this challenge, what we need to do is take a list of numbers and a value n. We'll write a function that returns the probability of choosing a number greater than or equal to n from the list. And the probability should be expressed as a percentage rounded to one decimal place. So to give a simple example, we could calculate the percent of probability of events by multiplying by 100 times the ratio of the number of favorable outcomes, so all those that meet the criterion, over the total number of possible outcomes. For example, if we have a collection of values, 1, 8, 3, 4, 19, and 40, and the number 17, the probability that a randomly selected number in the list is greater than 17 would be 2 out of 6, or 33.3, should be 3% to meet the specifications of our example. And this is just because there are two values greater than 17 in the list and 6 total values. Okay, so we have some examples set up here. The function, we can see from here that the function should be called probability because that's what we're referencing in the examples. We can see the two arguments are a list of numbers and then the number that serves as our boundary. So that's n that was referenced in the instructions. Okay, so let us get started with a function definition and let's just get something working. And then we'll go from there. Okay, so we'll call this probability. And we need two arguments here. So I like to use LST and we'll do num. Okay. So I know that I'm going to have to do a for loop at some point. So I'll do a for I in LST. That's the object with multiple items. And let's just, before we write any more code, make sure we have something working. Okay. Yep, we can access all of the numbers. The Python interpreter recognizes that the elements of the list are these individual numbers, so we can work with this. Okay, there are a couple ways we can do this. I'm going to suggest that we keep a variable called over, and we can continue to update the value of that variable anytime the condition is met. So we'll call this over and we'll start it with a initial value of 0. This is where we now need to add our conditional statement and add to that value as the condition is met. So what is the condition? So the condition should be if I is greater than n, greater than that number. And let's just print I to make sure that we've written something that works. There we go. So in each, what's happening is in each of the lists, we're taking a look at, we're seeing an output of all of the numbers that are greater than the value that is the second argument in the function. So we're printing 8 and 9 because those values meet this condition, right? And then in the second example, we're just printing 17 because that is the only value that meets this condition of the value being greater than the value of the number. Okay. All right. So we have that set up. Now it's time to adjust the value of the over variable. And we can do this by using incremental assignment. So we could do this the long way and say over equals the current value of over plus 1, because we just want to increase this count by 1 anytime this condition is met, because that's what we're doing. We're counting the number of times the condition is met, the number of values that are greater than the value supplied as the second argument. So we can then print over and see what we're getting in each case. So see, it starts as 1, then we get 2. This is making a lot of sense, right? Because now we have two values. In the first example, right, we start off with a value of 0, then we encounter 5, we don't increase the value of over, we encounter 1, and the next iteration, we don't increase the value of over. Then we find the 8, that's when the value of the over variable increases to 1. Then on the next iteration, we see the 9, and that increases the value of over to 2. Okay. And so in the second example, there's only 1. Um, and then in the last example, we have several values that are larger than the second argument. Okay, so don't be confused because this 6 and this 6 mean totally different things, right? This 6 means that there are 1, 2, 3, 4, 5, 6 values that are larger than this second argument. Okay, so that's how the over variable is working. We don't need to print that. We just need to record it. And we are done with the iteration and conditioning because we now have a value called over. And from here, we can calculate the probability using what we have. So the probability would be the over variable, the number of times the condition is met, divided by the total number of items in the list. And to get that, we know we can just do the length of the list. And we do want to multiply this by 100 so that we can output the value. Let's return P at this point to see the probabilities. Okay, so we are getting the correct probabilities. The last one should be 70. Let me go back and read the instructions again. Greater than or equal to n from the list. So my mistake here, this needs to be greater than or equal to, which is this. Let's see if that fixes everything. Yeah, okay. So just had to go back to the instructions to make sure I had all the right information. Okay, now we're doing good. Next thing we need to do is simply round. So I'll just reassign the value of P to be the rounded version. Round P to 1 decimal place as per the instructions, and then we get the expected results. Okay, so this is a solution to the probability problem. There are always lots of ways that this can be done. So if you're wondering if your solution is okay, if you are getting the correct output in all of these cases and it runs through CodeGrade where I supply extra inputs, then you are going to be doing fine with this problem. So there's no need to do it this way. I usually show a method that is easy to follow in terms of logic, but not necessarily the most efficient. Okay, thanks for your efforts on that exercise, and we'll leave it there.